Have you ever really thought about what's happening deep inside your automatic transmission the moment you feel it shift gears? Well, it's not some kind of black magic. It's actually this really precise, controlled dance between electronics and hydraulics. And right at the heart of that dance, you've got these incredible little components called shift solenoids. Honestly, they're the real unsung heroes of your gearbox.
All right, let's get into it. Here's what we're going to cover. We'll start with why the solenoid is the electronic gatekeeper. Then we'll take a peek inside to see how it works. We'll talk about the symphony of shifting, what happens when things go wrong, how a mechanic figures out the problem, and, this is the big one, how you can prevent these failures from happening in the first place.
So first up, the electronic gatekeeper. We're going to kick this off by looking at a really common problem that puts this little component right in the spotlight.
Okay, let's imagine this scenario, and maybe you've even been there. You're just driving along, and all of a sudden your car just slams into gear, or it hesitates. Or worse, it gets completely stuck and won't shift at all. So what in the world is going on? I mean, could one tiny little part really be the source of such a huge problem?
You bet it can, and the answer is right here in this system. See, your car's brain, what we call the Transmission Control Module, or TCM, is constantly watching your speed, your engine load, everything. It sends out an electrical command, but that little electrical signal can't move heavy mechanical gears by itself. It needs a translator, and that's the shift solenoid. This thing takes those little electronic whispers from the computer and turns them into powerful hydraulic pressure. That pressure is what actually gets the work done inside your transmission.
So how does this little device pull off such a critical job? Let's zoom in and really break it down. We're going to follow the journey from a single electron all the way to real physical action.
At its core, a shift solenoid is what engineers call an electro-hydraulic actuator. That's just a fancy term for a valve that uses electricity to control the flow of a fluid. And in this case, it's the gatekeeper for your high-pressure automatic transmission fluid, the ATF. It's basically the muscle that acts instantly on the brain's command.
And here's exactly how it happens, in 4 quick steps. First, the TCM sends a voltage signal. That current zips through a tightly wound coil inside the solenoid. And boom, an instant magnetic field is generated. This magnetic force is just strong enough to move a small metal plunger inside, overcoming a little spring. And finally, that plunger's movement is what physically opens or closes a hydraulic passage. It's a really slick, instantaneous conversion of electricity into mechanical work.
This cutaway shows that last step perfectly. You can see this solenoid on the left. When its little plunger moves, it pushes that larger spool valve right next to it, which is basically just a hydraulic slider. And that valve is what redirects the high-pressure fluid to a very specific clutch pack, causing it to engage. That action locks a part of the Planetary Gear Set, the whole system of interlocking gears, into place. And that is how your car changes gear. Okay, let's zoom out a bit, because a modern automatic transmission doesn't just have one of these things. Nope, it has a whole team of them, all working together in what's basically a perfectly timed hydraulic symphony. You know, to get all the different gear ratios, the TCM activates a very specific combination of solenoids. It's almost like a binary code. So in this really simplified example for an old 4-speed, you can see first gear might need solenoid A to be on and B to be off. For second gear, you flip it. For third, maybe they're both on. So just by flicking these little electronic switches in different patterns, the TCM can command any gear it needs whenever it needs it.
Of course, in the real world, inside a modern 8 or 10-speed transmission, well, it's way more complex. This diagram here shows a real valve body, and it is an incredible piece of engineering. It's this crazy, intricate maze of hydraulic passages, little check balls, and a whole bunch of solenoids. Some of them control the shifts, but others, like pressure control solenoids, are constantly fine-tuning the overall hydraulic line pressure to make everything engage smoothly.
And this really shows you how the technology has evolved. Older transmissions, they just used simple on-off solenoids. They were either fully open or fully closed, which could feel a bit abrupt. But modern transmissions use what we call pulse-width modulated, or PWM solenoids. The TCM can rapidly pulse the voltage on and off, which lets it feather the hydraulic pressure with incredible precision. This is the key tech that gives us those silky smooth, almost invisible shifts we feel in cars today.
So, what happens when one of the key players in this whole hydraulic orchestra decides to fail? Let's talk about the common symptoms, when the symphony just stops.
From the driver's seat, the signs are usually pretty obvious. You might feel a really long delay before the car shifts, and then, clunk, a harsh jolt. The shifting can become totally erratic, completely unpredictable. One of the classic and most dangerous symptoms is transmission slipping. That's where you see the engine RPMs flare up, but the car isn't actually accelerating because the gear isn't properly engaged.
And you can pretty much guarantee that check engine light is going to pop on.
And listen, this isn't just an inconvenience, it's a serious safety issue. Like the folks at Car Care Clues point out, if your transmission suddenly slips out of gear while you're on the highway, you instantly lose power and control of the vehicle. It's a situation you've got to deal with right away.
Now, to protect all the expensive hardware inside that transmission, your car's computer might actually trigger a self-preservation mode. We call it limp mode. It detects a serious fault, like a bad solenoid, and it locks the transmission into a single, safe gear, usually second or third. This lets you literally limp to a repair shop, but it's going to severely limit your speed and performance to stop any further damage.
So, this is the crucial part. How does a mechanic actually confirm that the solenoid is the problem? And what's really involved in fixing it? A proper diagnosis is a step-by-step process. The very first step is always to scan for diagnostic trouble codes, or DTCs. Solenoid problems usually throw codes in the P0750 to P0770 range. After that, a tech will do electrical tests, like checking the solenoid's internal coil resistance with a multimeter. Then, and this is critical, they'll inspect the transmission fluid. If it has a burnt smell, that means overheating. If it has metallic debris, that means parts are grinding together. Both are very bad signs. Finally, they might even do hydraulic pressure tests to see if a specific circuit isn't getting the pressure it's supposed to. And the repair itself? Well, it happens deep inside the transmission. As you can see here, to even get to the solenoids, you have to drain all the fluid, drop the transmission oil pan, and then very carefully work on the valve body itself. This is exactly why it's such a labor-intensive job. And that brings us to what I think is the most important part of this whole discussion: how you can avoid all these problems in the first place. This is truly all about prevention over cure.
The root cause of solenoid failure almost always comes down to one of three things. The number one reason, by a huge margin, is contaminated fluid. Think about it. Tiny metal shavings and clutch material floating around in the fluid act like liquid sandpaper. They clog up the solenoid's tiny passages and make that internal plunger stick. Overheating is another big killer. It just breaks down the fluid's protective properties and can literally fry the solenoid's delicate electronics. And of course, you can always have a simple electrical fault in the wiring.
So how do you fight that number one cause? Simple, with diligent preventative maintenance. Most experts are going to recommend a full transmission fluid and filter change about every 50,000 kilometers, which is roughly 30,000 miles. Clean fluid is the absolute lifeblood of your transmission. It is the single best insurance policy you can have for these critical solenoids.
So I'll just leave you with this final thought to chew on. A single solenoid replacement can easily run you hundreds of dollars, and a full transmission rebuild, we're talking thousands. So when you compare that to the relatively low cost of a routine fluid service, is there really any question about which one is the better investment for the long-term health of your vehicle?